Hi, everybody. Thank you so much for joining us. My name is Erica Pendergraph, and I'm the events coordinator here at AIA Los Angeles. We want to thank you today for joining us for practical considerations for specifying heat pump water heaters. Our esteemed speaker today is Nick Brown, president of BuildSmart. BuildSmart is an independent energy consultancy specializing in California energy modeling, energy code, and building performance that supports builders and architects in designing energy-efficient buildings. Nick is a certified energy analyst for residential and an associate energy analyst for non-residential construction by the California Association of Building Energy Consultants. Woo, I want to tell you more, but you guys already know it. Nick is amazing. What you're going to be learning today for your learning objectives, you will be receiving 1.5 LU HSW approved, plus the certificate provided for 1.5 hours towards your ZNZD portion of California license renewal. Today, you'll be learning to understand how heat pump water heaters work by pulling heat from the surrounding air, learning proper locations and ventilation requirements to ensure HPWHSs have an adequate source of heat and can be effectively maintained, compare operational carbon emissions of typical gas water heaters and HPWHs as part of a zero net carbon design. And lastly, you'll learn using case studies, see how to show HPWHS on plan sets to ensure smooth installation in the field. So it is my pleasure to welcome Nick Brown again. And Nick, please take it away.
Thanks, Erica. All right, you seeing that okay? Super. All right, this presentation is sponsored by Southern California Edison. It's also approved by the U.S. Department of Energy Skilled program as meeting certain requirements. I gave this for AIA San Fernando Valley a couple of months ago. It was well received. This isn't so much of the usual Energy Code ACE class. It's more of a how-to class. Based on my experience, I've been going around training plumbers on behalf of Southern California Edison and 3C REN on proper installation of heat pump water heaters, and finding that a large proportion of those plumbers are pretty new to this technology. Also, when I work with my architects, I do Title 24 compliance work. And so when I work with my architects, they're struggling to figure out where to put these and how to specify these and ensure good results. So that's why we thought bringing this content to AIA Los Angeles was a good idea. Also, I've got the chat up here, so feel free to put questions there. Or if you'd like to unmute, Erica tells me you have that ability as well. And I find architects typically not the shy retiring type, so I'd encourage that. And please, no need to hold your questions till the end. All right. So let's kick it off with this thought-provoking beginning. We got used to building with tank water heaters way back when. Probably most of us grew up in homes with storage water heaters. And then tankless water heaters came out based on a Japanese technology, the way I understand it, mostly because they don't have room for tanks in small Japanese apartments. Anyway, the technology took California by storm. There was a nice compliance credit for Title 24 to include them in our designs because they were quite a bit more efficient than gas storage water heaters. But now we're looking at the prospect of needing to find room for a storage water heater in our designs again, because heat pump water heaters have in effect superseded gas tankless water heaters in terms of efficiency and cleanliness and all those emissions, all those things. There's every indication that the state wants us to go into this direction. And so I'm sensitive to the fact that this is a challenge on your designs, especially small homes where space is at a premium, like ADUs, right? But it is what it is. And so I'm going to share with you appropriate locations. I'm going to hopefully have you leave understanding better how to specify these and make sure that they're installed appropriately so your clients get the results they want. So I was at a friend's ADU the other day, And here's the heat pump water heater. It was an all-electric ADU, back of the lot, pretty typical. And I took one look at this heat pump water heater enclosure and I thought, I don't know. Why do you think I thought that? It's not enough
Ventilation?
additional space. Not enough ventilation, not enough space. Yeah, exactly. Especially because heat pump water heaters tend to be a little taller than traditional storage water heaters with the heat pump on top of the tank. And sure enough, when you took the door off, it's not a heat pump water heater at all that got installed at this ADU, even though that's what was specified. The plumber installed an electric resistance water heater that's going to use 3 times as much electricity over the course of the life of this ADU than if they'd installed what was specified. So I just thought you'd laugh at this story. It shows that our industry isn't where it needs to be yet, and that you as architects, who are quite often the people holding these projects together, have an important role to play here. It's also funny they put it on a pedestal for no reason. Anyway, hope that gives you a little chuckle. So here's what we plan to present. Why we're here talking about these technologies at all, why we need them, how they're different, proper installation. We'll focus a little bit on some of the research around airflow so that you come away understanding just how big a room is big enough, how much ventilation is enough to make sure these function right. And then some guidance on sizing, makes and models, and climate. Sound good? Please, if there's anything you want to make sure I cover outside of that, drop it in the chat. But first, let's start with this. I'm a Title 24 guy. Maybe you're hearing from your Title 24 consultants already that it's difficult to comply with gas tankless water heaters, especially in new homes these days. I would be surprised if you're not hearing that. It's certainly what we've been finding because of the chart here. You can see the percent impact on efficiency, this first chart on the left, TDV energy, and source energy, that's emissions on the second chart. And we have a compliance metric in both of these areas now that has to be met. So if a heat pump water heater is 30%, 35% better than a gas tankless, you can imagine how hard it's going to be to comply with a gas tankless when a heat pump water heater is the standard design, which it is. Especially look at our climate zones, 6 and 7, coastal Southern California, 8 and 9, LA, 10, Inland Empire. These are some of the longest bars there are. So let's start there. And now let's move on to why this is a technology the state's so supportive of. We know the state wants us to go all electric on retrofits, on new construction. But for you, I like to say all electric has a big tent. It appeals to a really wide range of projects. Those who want simplicity and quicker startup of their utilities, those who want incentives, those who need to meet energy code and maybe have a difficult compliance project, those who care about health or have family members with asthma or other respiratory conditions, they can greatly benefit from not having gas combustion, especially stoves in the house. Those who want utility cost savings, we find significant cost savings possible when all electric designs are paired with solar, even more so when paired with solar and battery. And I'd add to this list resiliency. If you want your house to have the power stay on in case of one of these natural disasters that we're all getting used to dealing with in our area, well, solar and battery and all electric can do that. And the real reason the state wants us to go this direction is reduce pollution and much lower greenhouse gas emissions than how we've typically built homes. I quoted the 50% figure here, but the latest version of our energy modeling software, the 2025 software, shows 70% lower greenhouse gas emissions for an all-electric home compared to a mixed fuel home. And that reflects the change in the mix of electricity on the grid and the expected further changes on our way to our goal, which is 100% emission-free electricity by 2045. That's a goal that our legislature committed us to under SB 100. So electric homes really benefit from all of that. Here's that modeling result I just referred to. I compared a mixed fuel typical house like you would have built 10 years ago to an all-electric house that meets current code. And I'm just showing you the difference in greenhouse gas emissions, on average 70% lower for that all-electric home. And water heating, what we're here to talk about today, is the biggest single end-use reduction in these bars. If there's one thing you can do to reduce your home greenhouse gas emissions, it's switch to a heat pump water heater. And I wanted to share this latest quote from the CEC chair. They've studied PG&E territory and SDG&E territory because those are utilities responsible for turning on both gas and electricity, right? So when you look at those areas, 80% of new homes are being built all electric. And we know this for a fact because their applications would have come into the same place. Whereas in Southern California, we've got one gas utility, a separate electric utility. So it's a stunning number, right? And it's happened just in, I don't know, 5 years. And I've provided you a link to that press release if you want to read further. Underpinning the advantage of electric homes in emissions and energy efficiency is this latest figure. 67% of California's retail electric sales are now from zero carbon clean sources, if you include nuclear and hydro. So you build a house with gas, you don't benefit from this except on the plug load and the electric loads. You build all electric, you benefit from this. So I thought I'd share that update as we set the tone for why we're here talking about heat pump water heaters. This chart, you might have noticed on tech sheets, the manufacturers cite an efficiency or a COP of 3.5, which means efficiency of 300 to 350%. Seems too good to be true, right? So this install study in the San Joaquin Valley that I'm referencing here actually measured the electricity in, the hot water out, and calculated efficiencies in the real world conditions. And let me tell you, you'll see some pictures at the end of today. These were not all Sterling installs, but each one of these bars is a different house. And you can see they're performing in the real world between 250% and 370% efficiency, on average 270, with a wide range of flow rates of hot water. We do see slightly lower efficiency in high usage homes, as we'd expect. But the other good news is they're working reliably with no major complaints in the 2 full years of the study. So some of my clients have caught on to this trend towards all electric, and they've come to me for their project saying, I got this great idea. I want to use electric tankless. I know, Nick, you've been pushing me to do heat pumps and all electric. And so I found one I can afford, and here's what I'm going to do. But here's why these aren't the solution and why I want you to come away with the fact that the only efficient electric water heating solution is a heat pump water heater. Yes, there's no standby loss. And when we sold gas tankless water heaters, we did a great job of convincing everyone that that advantage of tankless is significant. It turns out tankless gas save a lot more than tankless electric relative to the storage, but let's not go too deep into that. And yes, they don't take up floor space. They're relatively affordable. Title 24 is going to crucify you if you try to use them unless you're in a new home less than 500 square feet, because there is an exception for electric tankless water heaters that allows for them in these small homes. But electric resistance, think of it like a toaster technology, is 3 times less efficient. So you're going to use 3 times the electricity to heat your water. You're going to need a ton of panel space because they need a ton of power, 60 amp circuits, even more in some cases. You still need to flush them like any tankless. You're going to suffer on Title 24 compliance. So the only thing you should be heating with electric resistance is toast. Another reason on the horizon to consider and get ready for heat pump water heaters is that some of our regulatory bodies have been negotiating, debating, doing away with gas furnaces and gas water heaters. Recently, South Coast AQMD, though, voted down the prohibition, the phase out of gas-fired water heaters. But Bay Area's AQMD has already passed similar rules. They'll be phasing out gas water heaters in 2027. Safe to say the writing's on the wall, even if it didn't pass this year. Another reason to consider heat pump water heaters, and this is fresh off the press, the tech program just came back with $2,100 rebates for if you retrofit from a gas water heater to a heat pump water heater. On top of that is the federal tax credits, 30% of the cost up to $2,000, additional incentives for electric panels. So just retrofitting your water heater to a heat pump water heater can easily result in almost $5,000 in incentives right now. So now's the time. Electrifying whole houses, much larger incentives possible through programs like California Energy Smart Homes. And I said all electric was a big tent. Here's a friend of mine, a client who's no tree hugger. Let me tell you, this was a single family lot in LA. He wanted to turn into this 4-story apartment building. And he said, it just doesn't make sense to me to run these gas lines through my building, but from a financial perspective. And so we were able to build this building all electric with a heat pump water heater in each unit or in the hallway off that unit, a ductless mini split heat pump, condensers on the roof. It, of course, required electrical infrastructure upgrades, but it met Title 24. And all electric works for a lot of people. I've got 2 of these running at my house. The one on the left is a 240 volt, 30 amp, 50 gallon typical model from Rheem. It's serving the ADU that I built above the garage. It's all electric. My tenants have no idea they have a heat pump water heater. They just know they have hot water. It worked, boy, it's up to 3 years now, and it was working so well that I retrofitted the main house, and in fact have completely electrified the main house too. Used to have a condensing gas tankless bolted to the wall shown in the middle picture. And as part of that tankless installation, it had a 120 volt outlet right there for the igniter and the fan. So I installed a 120 volt heat pump water heater in the same spot. It was as simple as plugging it right into that outlet and building an enclosure around it, which you see in the right picture. This is also from Rheem, also 50 gallons. It has no backup electric resistance element in it, whereas all the 240 volt units have backup electric resistance elements. Just in case you didn't know, the heat pumps are what's 300% efficient. The backup electric resistance elements are like your toaster, 95% efficient. So these are all programmed to run in heat pump mode and only use those backup electric resistance elements if they're falling behind or if the outdoor air is cold enough that the heat pump can't do the job. So keep in mind, if you install one of these 120 volts like I did, it needs to be in a climate zone where you don't need that electric resistance elements. Long Beach is just such a climate zone. Doesn't get cold enough that the heat pump can't do the work. Notice also, I used a louvered fence panel for the enclosure for the water heater. I'd studied this technology enough, I knew how important airflow was. And so I built this. It was very time consuming. It's not for everybody. Someone needs to start building these ventilated heat pump water heater cabinets like this one, because a louvered door should do the trick most cases, but even better to have more airflow. And they're running really efficiently and economically. The one on the left's the ADU. Each bar is a month's usage, so roughly 50 kilowatt hours a month. On the right is our main house, which has 2 to 4 people using about the same. So about $17 a month, very economical, especially because you can tell them I want to run in heat pump only mode. You can tell them I want to run outside of peak periods when electricity is expensive. There's a lot of nice technology built into these things. But the popular wisdom is that gas is cheaper. And so I modeled a typical new house on the left with solar and an existing house on the right without solar. And I modeled it with a gas tankless first and a heat pump water heater second, plugged it into my complex spreadsheet with today's electricity rates on a time of use basis. And here you can see there's some savings there to be had with a heat pump water heater, or in an existing house, it's roughly a push, just slightly more to operate than a gas tankless without solar. So that myth is a little overblown. You've also got no emissions, less pollution. You don't need that flue that's getting rid of the combustion byproducts or a powered exhaust. You don't need to worry about backdrafting. It's fresh water supply in case of a disaster. And at 400 watts, that's what these heat pumps are, you could easily run them from a battery, a generator, or even your EV. Any questions so far? Jim says no. Okay, what's different about these? And the main point we're making to plumbers is, look, this isn't earth-shattering different from what you're used to, but it is subtly different. So if you study with us these slight differences, you're going to have good results with these. If you put your head in the sand and try to rewind and press play on what they taught you 20 years ago, you're going to have problems. So air source heat pump water heaters get the energy they need from the air around them. They're not consuming a fuel. They're not burning gas or propane. They're not consuming electricity directly. They have a heat pump on top. And so this makes them very different from traditional water heaters. And that's why we need to pay special attention to the airflow around our installs. A quick review of past water heaters. Storage gas water heaters, as shown on the left, had a flue up the middle and a flame at the bottom, and that's how they heated the water. This, by the way, is why gas tankless water heaters were such a huge improvement over a gas tank, because they're very difficult to insulate and they had significant standby losses. They also have all these other features. Electric tank water heaters shown on the right had a similar tank style, but they didn't need that flue up the middle. They thus had less standby losses, and they typically had 2 electric resistance elements, one low and one high in the tank. Otherwise, the same as your gas storage water heater. Well, a heat pump water heater takes that electric style tank and puts a heat pump on top and prioritizes the heat pump as the first choice of heat source. And so that's what I installed in my garage under the ADU. Now, and they call them hybrid because they can run in heat pump or electric resistance mode. Now, the 120 I installed outside for the main house has a larger heat pump compressor, no backup electric resistance elements. Other manufacturers' 120-volt units have a small heat pump and small electric resistance elements. So do your homework and understand what it is you're buying. It's really the Wild West right now in terms of the different manufacturers' product offerings. They haven't all standardized around one set of products. We're talking mostly today about unitary heat pump water heaters where the heat pump is attached on top of the tank. But there are also split heat pump water heaters of the kind Sanco 2 makes, where the heat pump is separate from the tank. You can put that outside just like you would a heat pump for HVAC, and the storage tank can be inside or outside. They're more expensive that way, but the benefit is the noise moves outside, whereas the heat pump on top of the tank could be near living spaces, and the airflow's taken care of because now that heat pump portion is outside with plenty of airflow, and you don't have to worry quite so much about where you're putting that tank. The other concern we hear about heat pump water heaters, from plumbers especially, is you're going to run out of hot water. Okay, how do we ensure enough hot water? Well, we can have a big tank and a small heat source, or a small tank and a big heat source, or anywhere in between, really. And a gas tankless water heater is a small tank, big burner, right? And a heat pump water heater is more of a small heat source. So you need that tank as more of an inventory. You know, Amazon gets you stuff in a day or two because they have a ton of inventory in those big warehouses. So water heating is going to become, with heat pump water heaters, a little more of an inventory situation than having limitless heat source, which is what a gas tankless is. And I know your clients have all gotten used to unlimited hot water with a gas tankless water heater, and they kind of like that. But I would argue it's unnecessary. There are whole periods of the day where you're not using that at all. And a tank storage water heater is going to be just fine. So let's look at the numbers on that. We measured this with a first hour rating. It's measured in gallons per hour. And you can see the gas 40 and 50 gallon water heaters, first hour ratings, you know, in the 60s and 80s per hour. That's how many gallons of hot water you can get out of it if it's fully charged in an hour. Well, the heat pump water heaters of the same size have lower first hour ratings because once you start draining that tank, they recover more slowly. And that's what I'm showing on the right side of the screen here. The recovery rate is lower. So notice though, when you go to a 65-gallon heat pump water heater, you're getting close to that 50-gallon gas first hour rating. When you go to an 80-gallon heat pump water heater, you're equal to it. So this is why upsizing the tank compared to what you would install with a gas tank is advisable with heat pump water heaters. Notice that the plumbing code, which I'm reproducing at the bottom of the screen here, calls for different first hour ratings depending on the combination of beds and baths in the dwelling unit, but a 65-gallon heat pump water heater meets all of those on the chart. So don't think it's not going to meet code. It's got enough capacity for code, absolutely. Yes, Monica, we'll distribute the slides. So let's talk about how we get these installed right. First, they need an electrical connection. That may be a little bit different from your old tank water heaters. Some need 240 volts, some are able to use 120 volts, so study up on that. There needs to be an adequate supply of warm air because that's where they're getting the energy from. Think of it as the sun has heated the air and the heat pump water heater is harvesting that. Now, as it pulls the heat out of the air, the inlet air, it spits out exhaust air with that heat removed. So it's cold exhaust air, not freezing cold, might be in the 60-degree range, okay? So there needs to be a space for that cold air to dissipate. And that's why putting a heat pump water heater in a closet that doesn't have enough ventilation is going to result in low efficiencies and complaints about not enough hot water. And I'll give you an example of that coming up here in a minute from my practice. So if you think about those two items as you think about proper locations, you're going to be successful. Garages have an adequate supply of warm air typically, and an equally adequate room for that cold air to come out. They all have air filters too, and they need to be accessible for cleaning. Some pull out the top, some pull out horizontally. I'll show you a few examples, but we've seen many examples of plumbers installing these with the filters blocked, as if they weren't aware they were a maintenance item. They produce condensate just like your HVAC heat pumps do, and that can go straight to landscaping. It can go down the drain. It's just water. It's not toxic or anything, but it does need to be planned for. They make some noise in the dishwasher type range, generally mid 40 decibels to 50 decibels. And we've all gotten used to watching TV in the great room with the dishwasher running on the other side of the room. I would say this is similar, but you wouldn't want to put this in a master bedroom closet, right? Think about the noise. Mine turn on typically for half an hour to an hour at a time, a few times a day. And I tell it not to run overnight because it's on the other side of my master bedroom wall in an outdoor closet. So there are workarounds like that that you can do. Tell it not to run during certain times, but you'll want to choose generally a location where it can run without bothering anybody. Now, a great way to boost the capacity of these heat pump water heaters beyond the first hour ratings I just showed you is to hold a higher set point in the tank. Because if you have 50 gallons of 120-degree water, that's one thing. If you have 50 gallons of 140-degree water, well, that's almost 20% more hot water, and it's going to result in longer hot showers. To do so, you need a master mixing valve, which takes the hot water out of the tank and blends it with cold water to the desired temperature set point before sending it into the house. This is an anti-scald protective feature. The utility programs that are starting to come out with incentives for having these often require a master mixing valve because it means that heat pump water heater can hold more energy and do more load shifting. They don't work well with warm inlet water, so solar thermal preheat systems are not a good fit for heat pump water heaters. And in multifamily settings, you're going to want the recirc lines to not go back typically to the heat pump water heater as the inlet. You're going to want that to go into what they call a swing tank that just manages the recirc loop. So locations are really important to think about given that air is the number one thing, that inlet air, that exhaust air, as well as the physical space required, typically a 3-foot square footprint and about 8 feet of headroom. So corner of a garage is an ideal place, but interior closets, exterior facing closets, pantries, laundries are all good locations as well. If the room is on the smaller side, you're going to want that to be ventilated to a next door space so there's enough room for warm air to come from and cold air to go to. Basements are also a valid location, but what I'm seeing my architects do typically is an exterior closet. They have gotten used to not having that in the floor plan, and they'd rather not get used to finding it in a floor plan. But what isn't a good location is a small crowded closet without enough airflow, like shown here. That should be a fully louvered door or a high louver and a low louver, because what happens when you have high and low louvers is the cold air that's being exhausted tends to fall to the bottom of the closet and exit in the low louvers, while the inlet air comes in up top. Remember condensate removal. So as you're traveling around to your job sites, make sure that the plumber's disposing of that. Can't go to a bucket, can't go to the floor of the garage, can't be in the same pipe as the temperature and pressure relief valve. Giving you a link to a best practice install checklist here. Now you might have noticed my garage install is directly on the floor of my garage. And I'm sure you're all aware that most water heaters in a garage need to be up on platform. I naively thought, because this had no gas combustion, it would be just fine directly on the ground. I was wrong, because here's what the plumbing code says. It says it needs to be installed so that all heating elements, etc., are not less than 18 inches above the floor. Most heat pump water heaters have elements, so I should have put mine about 10 inches above the ground, given that the electric resistance elements are about 10 inches up. You'll notice these energy guides all look really good for heat pump water heaters. They'll list the UEF, the first hour rating, the estimated annual usage, and the first hour rating. Note that these are calculated using like 12-cent kilowatt hours, not our electric rates. Also wanted to quickly show, I'll let you look over this table, but only about 70% of the tank is usable hot water. This tank is stratified with cold city water at the bottom and hot water ready for use at the top. So the usable amount in a tank is less than the nameplate storage. And the amount of shower time you get out of these various size tanks depends on the gallons per minute of your faucet as well, of your shower head. And so we've got typically 1.75 gallon a minute shower heads. But if you have a client with a 5 gallon a minute shower head, well, when you get the heat pump water heater is a good time to upgrade those to code as well, or they're going to run through their hot water faster. Now, not all tech sheets list the heat pump capacity, but we've done it for you here. 4,000 BTUs per hour for most standard 240 volts, and the backup electric resistance are 4 times as much. But LG has one that's 10,000 BTUs per hour and variable speed. A.O. Smith has one. There you see the Rheem 120 volt that I put in my outside closet. It actually has a bigger heat pump, 12,000 BTUs. that's approaching the capacity of an electric tank water heater. When they say dedicated circuit, they're saying, I'm going to install this so that it has the full 120 volt, 15 amps of power. The shared circuits are designed to have other things using some of the power on that circuit. Okay, here's a case study from my practice. This was a couple who both did triathlons. They recognized the appeal of all electric homes, and they hired me to show compliance all electric. So we spec'd a heat pump water heater in the garage, which is shown here. What I didn't realize was they weren't putting it in the larger garage space. They were putting it in this exterior facing closet. And the main house is to the rear of us, the viewer here. You can see the hot water line going under the walkway here. So hopefully you all see the fault in their ways here, not nearly enough source of warm air or place for the cold air to go. And when we opened this closet, because they complained that they were running out of hot water fast, we also found a recirc pump. And that recirc pump was programmed to turn on at 5 a.m. and prime the lines so that whenever they got up, they'd have quick access to hot water at their shower. So much of the capacity of this tank was being used up to heat the slab between the house and the garage, heat the lines up, and by the time they got in the shower at, say, 7 a.m., the tank wasn't fully loaded anymore. We also found really high flow fixtures at the shower head. That line under the walkway is likely uninsulated. So this was the perfect storm of conditions that would make a heat pump water heater not work for this couple. Once we put a fully louvered door in, we switched their recirc pump to push button on demand, which the Title 24 requires these days anyway. Switched to a code compliant shower faucet. They were fine. Now, on the question of noise, I recorded a video on my cell phone of my gas tankless water heater before it was removed and the heat pump water heater. And hopefully the audio comes through here and you can hear the comparison, because to me, the noise difference is overblown. They both make noise, right? Maybe the heat pump water heater makes a little more noise. Take that into account when you choose locations. But certainly an exterior closet's not bothering anyone. A garage location's not bothering anyone. And tankless water heaters make noise too. You could all hear that? Okay. So generally these 240 volt units, ideal for new construction. You've got an electrician there to run the circuit anyway. And the 120 volt units are ideal for retrofits when you have that standard outlet nearby. But by all means, if you want to hire an electrician and run the 240 volt circuit in retrofits so that you can have that backup resistance element and peace of mind, by all means do it. The split systems, to me, solve the problem of when you don't have enough space for that tall heat pump water heater tank, or you have noise concerns, or both. So these are the questions to ask if you're getting complaints of not enough hot water. We covered that already. Of course, the filters being dirty is another possible cause. And you can set these up in heat pump only mode, and then if they're falling behind, put them in hybrid mode so the electric resistance elements will be enabled. If the utility bills are high, probably a similar root cause. Is there enough airflow? Is it running in heat pump only mode? And consider setting the schedule to avoid high time of use rate periods. All right, I don't see anything in the chat. Let me show you some of the configurations on the market today without saying what brand they are, just so you get a good takeaway. This one on the left is a top intake side exhaust. The filter pulls straight up out of that top of the cylinder. The next one is a top intake other side exhaust. The next one is a top intake rear exhaust. And the next one is top intake and top exhaust, and the filter pulls straight out horizontally towards the user. The last one shown is the one I installed outside, side intakes, top exhaust. The point here is they're all different, and for a given install, one of these units is going to have an ideally configured, laid out inlet and outlet, and another unit might not be optimal for that location. So it's good to get familiar with a few different brands. We've also got LG with a recent entry into the market, top intake, back exhaust, and there you see the Sanco 2s with the outdoor unit and various indoor tank sizes. Sanco 2, by the way, is a really environmentally friendly choice because it used carbon dioxide refrigerant, hence the name. Now, if you do multifamily projects, let me just spend a quick minute there because they make central heat pump water heater systems for large buildings like that. This company, Waterdrop, designs them for you, does all the engineering, determines what combination of heat pump capacity and storage is appropriate for your building, and then ships it to you. You can put this on the roof or on a concrete pad or in a parking garage and just plug it in, and it should work for you. Or you can hire an engineer to custom design a system like shown in the bottom right, also using Sanco 2 heat pumps, but they're connected to a storage tank inside and more of a built-up system. They also make big capacity commercial grade heat pump water heaters like Colmac, Nile, and A.O. Smith make. So they're well suited to replace that big central gas boiler in an existing multifamily building. But you'll notice this big ductwork here is helping ensure it has enough warm air that this mechanical room doesn't get cold. Also note that Title 24 requires solar thermal water heating panels when you use a gas boiler, but does not require solar thermal panels when you're using a central heat pump water heater. And expect to have more storage than with gas. If you've got a heat pump water heater, they've just got slower recovery rates. Richard asked the height of these. The integral tank units, they're typically 6 foot, 6'6", somewhere in that range. I've got some links to the tech sheets in the end, and you can click on one. But because of that heat pump on top of the tank, they tend to be taller than what we're used to a little bit. Thanks, Richard. So let me go quickly through this research that was done on airflow because it'll inform good location and good ventilation. This study Larson Energy Research did wanted to understand how big a room is enough and how do we ventilate small rooms to make them work. They took a heat pump water heater and changed the size of the room from 1,000 cubic feet They had a movable wall. They could make it 700, 450, 200, all the way down to a small closet, 84 cubic feet. And they ran it and they calculated the efficiency, the COP. On the left of the screen here is the wide open efficiency above 350%, which it is consistent with what the manufacturers claim. Put it in 1,000 cubic foot room, and already you have a little bit of drop off. About the same at 750, drops a little when you get to the 450 cubic foot room, drops a lot at 200, and drops way down in the 84 cubic foot closet. This is with no ventilation, right? This is just a closed off closet, almost to the point of the electric resistance efficiency shown here in a line at 95%. So that tells you that put it in a small closet, it's going to run in electric resistance mode almost all the time. And they tested a medium amount of hot water, that's the orange line, and a red amount of hot water, which is a high draw profile per day. Notice the more hot water you use, the lower the efficiency goes in a small space. You can see in the small closet on the right of this chart, most of the electricity use was resistance, whereas there was no resistance needed in 450, 700, and 1,000 cubic foot rooms. So what works? How can we avoid callbacks and complaints from clients? Well, they tested a bunch of different ventilation interventions for that closet scenario to see what worked. And the ones that performed the best, I would say anything that performs above 300% is achieving most of the potential of a heat pump water heater. I would argue is appropriate. If they did a large inlet, large outlet ducts, that was a 3.3. If they did a small inlet, large outlet duct, 3.26. But if they did a large inlet, small outlet, 2.1. So that shows you the importance of having that exhaust duct and inlet duct be large enough that it can move the air it needs. Fully louvered door worked, but half did not. Wall grills, upper only didn't work, lower only didn't work, but both did. In fact, it worked a little better than a fully louvered door. But I would say high and low and louvered door, you're going to be good. So those are the ventilation interventions that work. And you'll notice when the 25 Energy Code comes out, it includes some provisions along these lines. How much net free vent area do we need to make these closet locations work? Well, it turns out we need on the order of 250 square inches before we get up to that 300% efficiency range, like a fully louvered door or top and bottom grills. Note that they only tested in this study the 4,000 BTU compressors. And there are some on the market with 10,000 BTU compressors. Mine's 12,000. They're going to need proportionally more net free area to get enough air in and out of that closet. So keep that in mind. Richard asks about fire rebuilds and are you going to be required to provide a heat pump water heater? Probably not. You're going to find energy code compliance under the current code easier with a heat pump water heater. You're going to find you need certain other upgrades to make a gas tankless work. I promise you that. But you should be able to find a path to compliance with gas if that's what your client wants. But you're going to pay extra to do that. And so I would say all of these fire rebuilds are at least a chance to look at Give me an all-electric design, give me a mixed fuel design, and I'll go over it with the clients. My 2 cents. So here's some of that new language in the 25 code that addresses this airflow requirement. If you're not ducting the inlet and outlet air, the space needs to be 100 cubic feet per 1,000 BTUs of the compressor, or follow manufacturer recommendations. And if it's not that big a room, then the space it's in needs to vent to another room that gets you there. And then you see here the requirements on the net pre-vent area. You can also duct it, in which case you need to meet certain requirements for those ducts as well. So here's a checklist that I put together. This was for City of Moreno Valley, who asked for help understanding heat pump water heaters. Make sure the filters are accessible. Make sure the setbacks from the walls and ceilings meet the manufacturer requirements, because we're going to be pulling in or blowing out air, and we don't want that right up against a wall. Is there adequate warm air? Is there adequate room for cold air? Are the condensate and TNP plumbed separately and according to code? If the winter median of extremes falls below, in that region, below the temperature that that heat pump compressor cuts out at, then you need a backup heat source. If the storage temperature is set above 140, you need a master mixing anti-scald valve. If it's with a recirc pump, make sure that's on demand, and just make sure the tank size meets plumbing code. Any other questions before we look at some pictures and do a few case studies? We're at 1 o'clock, but we've got another half hour, so we're pretty good on time if you guys are. All right. So this is from that San Joaquin Valley study. Most of these were installed in garages because that was where the existing water heaters were. So what do you see here? This is a top inlet side exhaust setup. You think they've done a reasonable job? Does it seem like that exhaust air is going to be able to sneak by that wall? And I think so, right? They rotated the unit to make sure that wasn't directed right at the wall. You might notice the TNP, which is this flex hose here, is not installed yet. So let's hope they were in the middle of the install when this picture was taken, but that is not okay to just leave that hanging there. And they made use of the podium that was already there. That meets that section of plumbing code I showed you. Of course, the cold inlet is at the bottom here, the warm outlet up here. So this line definitely needs to be insulated. Hopefully they have access to that filter around this inlet line. Here's another one. What do you see here? This one has a master mixing valve. That's what's taking the hot water from the outlet of the tank, mixing it with cold water before it goes in the house. This outlet's really nicely directed, isn't it? But not much headroom. Let's hope they've moved this platform out far enough that we can access the filter, which is going to pull straight out from the top there. Here's another one. What do you think they were trying to do here? That's the outlet that we're looking at in front. You see a fully louvered door, which is open here. Anyone have an idea? Maybe directing that cold air out of the closet was their goal. But as I showed you, the fully louvered door is going to accomplish that just fine with the cold air falling and exiting low on that louvered section. Here's a Jetsons looking install. The reason I wanted to share this with you was the inlets on the top of this unit. And it looks to me like this installer made use of the old combustion flue as the inlet air. It's not nearly the diameter we need to get enough air to this unit. And this unit's going to struggle. The outlet air is reduced as well. So make sure your clients follow manufacturer recommendations on sizing those ducts. Here's one in a fully louvered door closet. This one hopefully stands a chance of working all right. But how many of you seen louvered doors painted shut after 10 times? Yeah, we're going to need to make sure that doesn't happen too. The outlet's facing right at a wall, isn't it? You see that on the right? Might have been better to rotate that a little bit. Here's another podium install. And if you look at the top, the filter is completely inaccessible. It's this black plastic rim here, needs to be pulled out. It's impossible that this owner can service their water heater. Just terrible. And all of these plumbers were supposedly trained on proper installation. My sister got one installed. Her contractor never told her it had a filter, and turned out he didn't even include the filter. He must have thought it was packing material and threw it away. Okay, this is my favorite one. What do you guys see? Is it ducted? What are you seeing? Outlet air clearly has a big duct and seems adequately sized. What do you see going on the top? Jim's got it. The dryer's right there. And instead of blowing that hot, moist air with lint in it outside the way code requires, or even common sense would require, they're blowing it to the top of the heat pump water heater. Good idea? Yeah, not enough inlet air and also full of lint. And so this unit was a very poor performer. They were trying to give it free hot air, but not a good idea. Clean air is more important than trying to boost its efficiency by giving it hot air from the dryer. Last picture, this is a new ADU. They put it in a laundry room with a fully louvered door. Good idea, because this laundry room is probably a little small for a heat pump water heater that's running a lot. And they put it in the corner. This is a top inlet back exhaust configuration from Bradford White. So the installer set it off the wall on the left side, set it off the wall in the back, but manufacturer specs say 7 inches to make sure it has enough room to get that cold air out. So it didn't quite meet that, but partial credit maybe. So before I close, let me share a few floor plans from my practice with you. You can you'll feel very comfortable with these on the screen. And I'd ask, what would you do if you needed to make room for a heat pump water heater in this floor plan? Starting with this one, was an addition project. The existing water heater, as shown here on the left side of the screen, is being removed. The new floor plan looks like this, and the architect chose to put the new heat pump water heater at the top of the screen in an exterior closet. Is that what you guys would have done? Any other ideas? Put it next to the condenser? Sure. Yeah, that would seem a good neighborhood for them both to be in. You think you could find room in the house to put it? Or is that something you guys try not to do? Garage, yeah. That's a detached garage, so you got to figure out how to get the hot water to the house. But when you've got an attached garage, absolutely, that's the first place to look. Yeah, there's some closets that might be good candidates, I thought. Let's look at the next one. This one's a little tougher. This is a new 2-story ADU, and it's built, very contemporary LA style. And this architect hasn't thought about the heat pump water heater at all. You guys have any ideas where you could put it? Anyone think about putting it in the kitchen? Or is that something just never want to do? LG makes a heat pump water heater that they've tried to make look nice enough that it could be at home exposed in a house. Anyone think about under the stairs, maybe? Yeah, right. Jim's suggesting maybe a split system in this case where the tank's under the stairs and the condenser's on the roof. Good solution. You notice it's a pretty suitcase style condenser. It doesn't take a lot of floor space. Richard, you're probably right. There probably isn't enough headroom under the stairs to do an integrated unit unless you've really planned for it. So that's my message to you. If you're finding on your projects that heat pump water heaters are becoming more and more common, I hope you start providing for them like this architect did. This was an addition project. And you see they carved out an exterior facing closet from the beginning. Made my job easy. This should be labeled fully louvered door, right? You guys probably have some ideas for notes you might put on your plans when you're specifying a heat pump water heater. Oh, incidentally, in terms of Title 24 credit, you might have noticed when I put that bar chart up, you get more credit if you specify a particular make and model heat pump water heater than if you just specify a generic tier 3 heat pump water heater. So it behooves you, if you want to squeeze that last compliance margin out of it, get familiar with with one or two makes and models and specify them on your projects. Jim, a closet, generally 3 to 4 feet is going to be that footprint you need in order to make the connections for the hot water. On new construction, you might be able to keep that a little tighter because you're, installing the pipes while you have the water heater. On retrofits, from what I find, there's a lot of rework on the plumbing to mate up with the new heat pump water heater that generally requires shifting it out a little bit from the wall. Good question, Brian. What if we took the air from the inside? There's some climate zones where that's going to be beneficial, like the Sierras, right? Because if that's an outdoor facing closet in climate zone 16, where the temperatures are regularly falling really low, below 40, which 40 is generally the cutoff for a heat pump compressor of a standard type, then your heat pump water heater is going to run more efficiently using located inside or using indoor air. Of course, it's going to throw out cold air unless you duct that outside that your heating system's going to have to reheat. But yeah, when I run my models with heat pump water heaters in the Sierras, they perform much better with an indoor location. The reason a kitchen location is kind of attractive for a heat pump water heater is a fridge puts out heat all day long, right? Which is going to boost the efficiency of your heat pump water heater. And I'm sure you guys can think of applications where locating a heat pump water heater where there's a free source of waste heat would be possible. Leo asks about what he can use the cool air for. I've often thought about a combination heat pump water heater wine closet. For that reason, use that free cool air to keep that space your wine's stored in a little cooler. I'm sure you guys can think of other applications for that. Now here's an interesting one. This is an existing single family dwelling on the left of the screen here. They're adding an ADU in the back corner of the lot. I see a lot of projects like this. I bet you guys do too. So where would you put the heat pump water heater, given that the ADU already has 2 walls it can't use? They're right up against setbacks. They've got a concrete patio planned for the upside and a covered patio for the left side with a barbecue. Presumably all the square footage of the ADU is spoken for. So what are our options? We recommended to this client that they put the hot water heater in the laundry of the main house to serve both dwelling units. And there's nothing prohibiting a heat pump water heater serving multiple dwelling units. In this case, the hot water lines could just run across the covered patio to the ADU. But maybe you guys have some other ideas. Of course, this ADU at 362 square feet would qualify for the electric tankless exception. So you could put an electric tankless on the wall here if you so chose. Just going to be more expensive to run and need more electrical panel capacity. All right. So when you talk to your clients about heat pump water heaters, be sure to explain to them that they're not using a fuel for every BTU they put in the water. They're taking heat from the surrounding air, and therefore there's a real need for airflow. Otherwise, you might find your homeowners stacking all kinds of stuff around their water heater, unaware of how it interacts with the space around it. Learn the different options of products from the various manufacturers, the 240 volt, the 120 volt. Learn how to upsize the tank compared to the tank you would have specified with gas, and use those venting options we showed you that work: louvered doors, ducting, or top and bottom. And then I just provided you with the links to the latest models here from A.O. Smith, Bradford White, and Rheem, who are generally the big three water heater manufacturers, as well as their 120 volt units where applicable, as well as Switches On's training hub. That's where contractors need to go for training to be pre-approved for that tech rebate, or $2,100. And then on page 2 here, the links to LG, Rinnai, Noritz, and GE just introduced a new one. They were one of the early heat pump water heater manufacturers, sold that business line to Haier, and now Haier's just reintroduced a new one with some pretty appealing functions, including they come with 120 volt and 240 volt capability, so you can start it up in plug-in mode until the electrician can get there and run the 240 volt circuit. So my pitch to you on heat pump water heaters is that this is where California appears to be going. So there's every reason for us to start to get used to it. In my experience, they work. If you pay attention to airflow, they're affordable to run, zero emissions, especially combined with PV, they're affordable to run. And we've had real good luck speccing them and operating them here at my house. I've given you my contact there. I'd love to hear your personal experiences, challenges with them. And I'll include in the slides I send a recent study by Gary Klein, who I teach some of these classes with, on what he found with condensation risk with the cold exhaust air and heat pump water heaters. But we don't have time to go over that today. So I'm going to stop sharing there. Would heat pump water heaters work in places like Joshua Tree? Yes, with that backup resistance element. You're going to need that 240 volt with the backup resistance element if you're installing them in an exterior facing closet or a place that's pulling in outside air, or alternatively, that's climate zone 14. We've put some there in interior spaces as well. Yeah, Brian, I often get this question. How much colder is it going to make a garage? I find negligible in an uninsulated garage. No difference. And I'm monitoring the temperature in there because I have a heat recovery ventilator for the ADU. So yeah, I really don't see an appreciable difference. Remember, the heat pump's 4,000 BTUs per hour. So if it's running an hour, that's only 1/3 of a ton of cooling that it's adding to that space. And that's not counting the heat of the compressor. So it's significant enough that our modeling software accounts for it. It's significant enough, especially with the 10,000, 12,000 BTU heat pumps, that you should think about it, but you're not going to find it makes a huge difference on comfort, in my experience. Any other questions? I hope you found this worthwhile. What are your personal feelings on heat pump water heaters right now? Are you speccing them a lot? Have you had problems? Is it working smoothly? Anyone care to share? Oh, good, Leo. Maybe you feel a little more comfortable. Okay. Okay, Lisa's just getting started. Yeah, Richard, I'm surprised to hear that report that your contractors don't like them. Even SCE employees that I work for under my contract, when they ask a plumber to install a heat pump water heater, and they should know better than to try to talk Edison employees out of going all electric, they do so. They try to talk them out of it. So my experience is that, and we've probably taught 14 different plumber groups now over the past couple of years. And in my personal opinion, they're just not that familiar with them yet. If they do new construction work, remember I showed 80% of new homes are typically going all electric now in California. Okay, then they're going to be familiar with them. But if they're doing retrofit work, as most plumbers maybe are that you're working with, yeah, they're unlikely to be familiar with them yet unless they're progressive-minded plumbers. Wow, Ryan, you're finding you need 3 of them for large homes. And that's based on engineering calculations or more the size of the home. Aaron's learning, getting comfortable. Well, that was the idea for this session, so I hope you found it helpful. Okay, MEP engineer. Yeah, remember if you're concerned about that, the higher temperature set point in the mixing valve can help, and go to the 80 gallon by all means. Yeah, clients still prefer tankless if possible. For me too. How do they perform in high humid environments? Very well, because that humidity is actually extra free heat once that hits the compressor and condenses. So you want, if you can put them in a hot, high humidity environment, that's good. Although there is a limit on how hot they're comfortable too. They do have electronics, so 120, 140 degree attics aren't the best location. All right. Oh, I'm glad you thought so. Erica, you want to bring us home?
Yes, everyone. I almost feel it because like Nick, you're so great. I want to do like a round of applause, but like it might be too much to be like everyone unmute. But yay. Nick Brown, everyone. Always a pleasure to have you teaching this to everybody. A reminder to everyone that we will be this is recorded, so we will be putting this on our YouTube channel. Also, Nick will be providing his slides. We will get that up on the website at the end of this. Everyone who was here for the full amount of time will receive credit for today. So look for that to show up in about 10 business days when Steve Tanner, our membership director, will be reporting. And that is it. So if no one has any other further questions, we're going to stop the recording.
Thanks, Erica. Good turnout too. 28 people. Thank